Welcome, Chemistry 1B, Unit 5, Video Example 5. This is the final example with the method of initial rates, and it's quite a complex one. So this is the information that we're given for this reaction. You should have seen this one before. We've used it before, where we have the rate of disappearance of the bromate anion with time. And we have three different concentration species, as there are three reactants that are going to disappear. All right, 4 experiments were carried out, as can be seen in the table. Now what we need to do here is we need to look at each one and hold 2 others constant. So for example, let's look at experiment 1 and 2. Okay, you can see that the concentration of the bromate ion here doubles, while the bromide remains constant and the H plus remains constant, and something happens to the rate over here. Okay, then we need to hold the bromate constant and vary the bromide. So we can do that probably with experiment 2 and 3. Okay, so here it's constant, here is a change, and here it's constant. And again, we can look at what happens to the rate. You can see the rate doubles there. And then finally, we need to see where does the concentration of the bromate and the bromide remain constant, while the H plus concentration varies. And if you look carefully, you will see it's experiment 1 and 4. You can see here there's a constant value there, there's a constant value there. However, the value doubles from there, and what happens to the rate of reaction is almost a quadrupling happening there. Watch the powers. You can see this is 10 to the minus 4. The others are 10 to the minus 3. Okay, so let's go. Let's have a look at this. And we see, first of all, when we compare experiment 1 and 2, we can find that we have the rate values and all the other values for, this is for the bromide. This is for bromate, bromide, and H plus, right? So we know that bromide and H plus cancel, and we can work with the bromate only and the rate. So the rate doubles. You can see here's the rate doubling. This relationship here results in 2. So 2 to the power m equals 2. That means m is equal to 1. Okay, so there we've established what the value of m is. If we now compare experiment 2 and 3, as we said that we should, again, this is for the bromate, this is for the bromide, and this is for the H plus. So the bromate and the H plus are being held constant. What happens to the rate? You can see that it doubles. Again, the concentration of the bromide ion doubles. So 2 to the power n is now equal to 1. And finally, we can compare 1 and 4 as originally seen on the first slide of this example, where we see that the rate quadruples, okay, and we keep the bromate and the bromide constant, but now we vary the H plus concentration, and we see that where the rate quadruples, we get a value of 2 to the power p, and therefore p is equal to 2. So finally, we see that it is first order in bromate and bromide, yet second order in H plus, and then we can determine the overall order as 4. Remember, it's 1 plus 1 plus 2. The overall order is 4, and the rate law is given as that. Again, if you wanted to, you could have calculated the rate constant for this reaction, but it wasn't called for at this particular time. But you can do it. You can take any of the values of the experiments, plug them into this rate expression, and calculate the value of K.